So let's check this exam problem. We have this shown beam. It is said here in the problem that it carries a uniformly distributed load of 1.75. This is the surface dead load in addition to its own weight, and a uniformly distributed live load of 3 kips per foot. 5 number 9 bars running the full length of the beam are used as flexure reinforcement. This is the flexural reinforcement, not the shear reinforcement. FC equals 4000 psi and F field equals 60,000 psi. And number 3 stirrups are used, number 3 bars. The concrete cover in the longitudinal steel is 2.5 inches. What is most nearly the theoretical spacing of the stirrup at a point where the required shear strength is 60.2 kips? So here we have the required shear strength, which is 60.2 kips. So actually all of these data in the beginning of the problem are not useful for you at all. You don't even need it. They are here only to confuse you a little. The surface dead load, the live load, the longitudinal reinforcement, all of this is not needed for you. You just need the required shear strength, which is 60.2, and you have the bars, which is number 3, which is used for the stirrups. You want to calculate the spacing between these stirrups. So in order to do that, we will start first by calculating D, which equals the total depth, which is 24, minus the steel cover, which is mentioned here as 2.5. So D equals 24 minus 2.5 equals 21.5 inches. After that, we will calculate VC, which is the shear strength of the concrete section itself, which equals 2BD root FC prime. We have the B, which is 14 inches here, which is the width of the beam. We know the D now, which is 21.5 inches, all multiplied by root 4000, which is the FC prime, equals 38,000 pound or 38 kips. So now we have the VC, which is the shear strength of the concrete itself, but we know that the required shear strength is 60.2. This means that the concrete itself is not capable to withstand just the shear force without additional steel. So now we know that we have to get additional steel. In order to calculate the additional steel required for the shear, we can get it from this equation, which is Vs equals V ultimate over phi minus Vc. And we know that the V ultimate equals 60.2. It is mentioned here in the problem. We know that the phi for the shear equals 0.75, and we have now the VC, which is 38.07. This means that Vs, which is the required shear strength for the stirrups, equals 42.2 kips. And it is mentioned in the problem that we need to use the bars number 3 as stirrups, and the cross section of the bars number 3 is 0.11 inch square. We know that the stirrup is going to have 2 legs as shown here in this sketch. You can see here this part, you have 2 legs of the stirrup, so the total area is 0.22 inch square. So we now need to calculate the spacing, which comes from this equation. S equals area steel multiplied by F yield multiplied by D all over Vs. We have the area steel, which is 0.22 multiplied by 60, which is F yield, multiplied by 21.5, which is D, all over 42.2, which is Vs. We get that the spacing equals 6.73. So this means that the maximum spacing for the stirrups equals 6.73. So the answer is the third option we have here, which is 6.7 inches. So this is it for our video today. See you in our next video. Thank you.